we'll just give the basic definition of ordinary differential equation. A differential equation is an equation in which differential coefficients occur. And differential equations are of two types. Differential equations are of two types. One is ordinary differential equations, ordinary differential equations. The other one is partial differential equations. These are the two kinds of differential equation. A differential equation is an equation in which differential coefficients exist. And what is an ordinary differential equation? The basic definition of ordinary differential equation. It is an equation in which it is an equation in which a single independent variable enters either explicitly or implicitly. Either explicitly or explicitly or implicitly. So that contains only one independent variable. So as per the definition, there are many definitions of an ordinary differential equation. Is a differential equation containing one or more functions of the independent variable and the derivatives of those functions. That also we can get. Another definition, it is a differential equation. It's a differential equation containing one or more functions, or one independent variable or one independent variable and the derivatives of those functions, and those derivatives of derivatives of those functions. Okay, so this is also a definition. will deal with some examples of an ordinary differential equation. Some examples. What are the examples? See here, it will be like this. Suppose dy by dx equals to 2 sin x. This is a first order equation, and see here this y equals to, y is a function of x. Here this is the dependent variable and this x is the independent variable. So what are the things available in this equation? The derivative of this dependent variable. What is the derivative? Y dash of x. That is dy by dx, and this is a function of the what? Suppose I say this is a function of x. F of x equals to sin x. This is a function of, what is x called as? X is called as the independent variable. You can see it's an equation in which a single independent variable enters. This contains only single independent variable, which is a single independent variable x, either explicitly or implicitly. So what is the other definition says? It contains one or more functions of the one independent function. See here we contain only one function of the independent variable x and the derivative of those functions. See here the derivative of this function which is unknown, that is y. See actually this is the differential equation. We are going to solve this differential equation. Solve means we are going to find this unknown function which is a function of the independent variable. We are going to find what is y equals to f of x, sorry, y of x. We are going to find. Well, various methods are available for different differential equations. Okay. So this is a simple example, and another one. Suppose b square x by b r square plus m square x. This is a second order because it contains second order derivative here. Okay, the differential coefficient is like this, and here the independent variable is r. The independent variable is r, and the dependent variable is x. Dependent variable is x. You can see here, and to solve this differential equation, we are going to get what is that x, which is a function of r. This is what we are going to do. There are various methods we are going to discuss one by one. And the next one is like this: x square d square y by dx square plus 2xy into dy by dx plus y equals to sin x. And this is also an ordinary differential equation which is second order. And see here, so first the independent variable, you can see here the independent variable is x, and the dependent variable here is y. You see here we have the function of x. Okay. So this is a ordinary differential equation. We have to find what is y, which is equal to a function of x. This is what is required to be found. These are all ordinary differential equations. And the partial differential equations we will discuss at present. What is the order of an ordinary differential equation? What is an order? It is the order of the highest derivative occurring in it. It is the order of the highest derivative occurring in the differential equation. For example, this differential equation. See, there are the derivatives. What are the derivatives? This is second order derivative. This is the first order of the unknown function y. So, which is the highest order present the second order. So, the order of this differential equation is 2. Similarly, you can find here what is the highest order present here 2, because the second order derivative of the unknown function is present here. So, this is second order. Similarly, this is a first order. The order of the differential. What is called as a degree of a differential equation. And if a differential equation can be expressed as a polynomial equation in the derivatives, the differential equation can be expressed. Differential equation can be expressed as a polynomial. As a polynomial equation in this derivatives, polynomial equation in the derivatives, then the degree of the highest derivative when the differential coefficients are cleared, the differential coefficients are cleared of radicals and fractions, is called the degree of the differential equation. Is called as the degree of the differential equation. The term degree is not applied to differential equation. The term degree is not applied to the differential equations, which cannot be expressed as a polynomial equations, which cannot be expressed as polynomial equations in the derivatives. So, if we are unable to express the given differential equation as a polynomial equation in its derivatives, then this term degree is not applicable to the differential equations. Now, we will include some examples. Now, you see here for this differential equation 1 plus dy by dx the whole power 3 by 2 equals to a into d square y by dx square here See, for this differential equation, first we have to express it as a this differential. This is a ordinary differential equation, that is true. But here this equation we have to express as a polynomial in the derivatives. What are the derivatives present in this differential equation? This is a second order derivative and this is a first order derivative. We have to express this totally as a polynomial in its derivatives. So this left hand side you can just square on both the sides. Squaring on both the sides, what happens is dy by dx, we get cube here, and we get squaring on both the sides. So a square into d square y by dx square the whole square. So now we express as a polynomial in its derivative. You can expand this one, a plus b the whole cube. So there will be definitely a polynomial in its derivatives. So now you can see here this is expressed as a polynomial in its derivatives. Now which is the highest order present in this differential equation? This is the second order. This is first order. So we have to look out for, after making clearing the radical making it as a polynomial in the derivatives, then we have to choose the highest order present in this differential equation and we have to check for its degree.